Great. Okay, hello everyone. Yes, my name is Mike Coulthard. I'm with Diamond Consulting. Very happy to be here. Thank you, Mark. It was super interesting. I apologize I missed the last presentation. I'm going to be giving an overview of urban forest planning. So as Mark was talking very specific about certain sites and projects, I'll be talking about municipal level planning, which is what we do a lot of here at Diamond Consulting. I do have quite a few slides. And I'll run through a number of them fairly quickly. I apologize just because there's not a lot of time. Our company basically is a consulting firm. We've been around for 20 years, about 60 staff. We have a number of different divisions. So we have planning, biology, arboriculture, wildfire and forestry. And then we have an operational division that is tree care and restoration work. So we do everything from sort of a citywide level down to operational work on the ground, which gives us a good sort of scope of understanding of how, I guess, some of the policies at a municipal level can relate to how things are done actually on the ground. At a municipal level, what we do a lot of are urban forest strategies, which I'll talk about mostly today, but there's a whole bunch of other environmental policies and planning projects that are very much related to trees and natural areas. Biodiversity strategies, there's a lot of work being done on those lately. Environmental policy related to enforcing the management of natural areas and trees. Park and natural areas plans, invasive species plans, very interesting stuff. Mapping ecosystems, trying to figure out what's on the ground, and community wildfire plans. These are some of the different forestry plans that we've worked on recently. Mostly in the Lower Mainland. We're doing some in Western Canada, working with Bellingham is our first project in the States right now, and doing quite a bit of work in Melbourne, Australia. So a bit of a wide scope. Now it's kind of interesting because they all have a similar overall objective, but they often get there in a different way, and they have very much different sort of goals and priorities that come out of them at the end of the day. And I'll try and cover those differences today if I can. I don't think I need to get into too much detail with this group about why trees are important, why natural areas are important. I do think that what's important is that there's an emerging field and new studies that are really proving not just the environmental benefits, which everybody can understand, but the economic benefits and the social benefits, and in particular, trying to quantify those benefits. So putting a dollar value on those, for example, for the economics. So for example, there's some modeling now and some studies which we feel are getting better, looking at the value of a single tree. So this is an example of the value of a single oak tree in a park setting. And they relate these dollars to avoided stormwater, air pollution removal, carbon sequestration, and amenity value. And so these are very important because we're looking at, with urban forestry, there's a lot of costs which go into planting and maintaining trees. And so there needs to be an idea of what the benefit is, and it does help to have a dollar value to work with. Mark touched on this as well, of course, threats to trees in our urban forestry. As we know, with new subdivisions, new planning, densification, is what's happening, which is done for different reasons, but with having closer structures, closer roads, infrastructure, of course, there's not much room left to retain large trees. We have huge trees here on the West Coast, which is amazing. We're so lucky. However, they need a lot of space. So with a lot of new subdivisions, there's not a lot of space to retain the existing trees. And as well, the trees that go into those places need to be designed properly. They're not going to be the huge, beautiful trees we see in our natural setting. They're going to be smaller varieties that can grow to smaller size and smaller soil volume. And we see all over Vancouver and the Lower Mainland what happens when, over time, street trees grow to their mature size. They look great when they're first planted along the streets, but once they get older and mature, they really outgrow that space, and they cause all sorts of infrastructure conflicts and problems down the road. So a lot of urban forest planning is really determining the right species for the right space and ensuring that what you're planting there is going to grow and be healthy in the long term and not cause long-term problems for the city. Mark touched on this very well. Of course, we know that with stormwater runoff, the more impervious surfaces we have, the more stormwater runoff we have. That runoff runs across hard surfaces, roads, pavements, collects pollution. It runs into our water courses downstream eventually and causes lots of problems for water courses. So that's one of the things that's getting quantified well in a dollar value, which is a very, very interesting field and becoming more of a justification for urban forestry and green infrastructure. Of course, climate change, we're going to have, we all know, more extreme temperatures, greater storms, flooding, sea level rise, invasive species coming in, pest and disease outbreaks. In the Lower Mainland, we're seeing, well, not just Lower Mainland, but also in natural areas in the Southwest Coast. Western cedar is really struggling right now with climate change. We have there's a couple of pest and disease outbreaks, which are, I feel, larger than normal and can be attributed to climate change. So a lot of sort of threats and impacts on our urban forests as our climate changes. As we lose trees in the city center, you get the heat island effect. So less trees, more paved surfaces. This is very well documented. You get more heat. This is attributed to a lot of health concerns with populations. So another reason, of course, to manage our urban forests. So when we get into urban forestry, again, we're looking at ecosystems, we're looking at social, benefits, human health and wellness, and we're looking at economic benefits from having a healthy urban forest. This is a diagram just sort of providing an overview of what the benefits are of a healthy urban forest, and I think most of us can feel that when you're in a well-treed, a healthy treed neighborhood in the middle of summer, in the middle of August. You can feel the benefits of a healthy urban forest. A lot of with urban forest strategies, a big part of it is consultation with the public, which is always challenging. It takes a long time, but it's very, very important. And trying to describe and illustrate exactly what the benefits are is a big part of that. Okay, so when we get into urban forest strategies, the first thing we do is look at what's going on with the canopy, with the trees. In general, this is actually a satellite study that was done that shows the canopy loss across Metro Vancouver. So this is showing in red, the canopy that's been lost over the in a period of 15 years. I'll get into some satellite technology later on, but some really interesting stuff being done with satellite tracking of canopies. But generally what we do to start with is you look at canopy cover as the measure for your urban forest. So basically canopy cover is if you're looking at a bird's eye view of the landscape, how much of that landscape is covered with the canopy of a tree. And how we measure this, and this is the technology part that's really exciting and just gets better almost every year, is the best way to do it now is with LiDAR. So LiDAR, if you're not familiar with it, is basically a plane flies over a city or an area and beams it with sonar and receives back just millions of points of data of reflection off the surface. And you get this 3D sort of a 3D image of points, which can then be teased out at different levels. That gives you a good idea from the ground level up to the tops of the trees what exists. And it's extremely powerful, and the technology for processing it and analyzing it is getting better and better. And so you can tease out where the trees are, how high those trees are, where the buildings are, where the ground level is. It's extremely powerful and very exciting to work with, and it's, as I've seen, it's getting better and better every year. It's amazing. So in addition to trees, for example, this is a project we did in Port Moody where we're looking at some ESA areas, and this is the ground, not just trees, but the actual ground level. But you can see what we're able to do here as a desktop exercise is very accurately identify where the streams are. And if you have riparian policy that's measured back from the tops of banks of streams, not the stream itself, we were able to identify and draw where the tops of banks are to a very high level of accuracy. So then that information can be portrayed to landowners and developers and prospective buyers as to where those riparian setbacks realistically are in a land base. So very cost effective for what you get out of the technology. It's amazing stuff. So this is an example from Vancouver's canopy. What we do is we look, basically we have use LiDAR to tease out where all these tree canopies are. Then we can look at the canopy cover in different ways. For Vancouver, it was by block or by large parcel or natural area. And then you can display that in a variety of ways. A very important statistic that comes out of this, and a big part of the urban forest strategy, is looking at where those trees are in relation to land ownership. So are those trees on privately owned land? Because there's only so much that a city, for example, can do to influence what's done on private land, and which ones are on public land, which ones are in streets, which ones are in parks. Those areas, of course, the city has more ability to influence and manage. With LiDAR as well, we can also look at impervious surfaces, pervious surfaces. So where are, how does that look across the landscape? And how this graph on the bottom left shows sort of how tree cover changes with permeability, which is very logical. As you lose growing space, as you lose your impervious surface, you lose your tree cover. And then you can combine those two together, do all sorts of things with the data. Look at, for example, some heat mapping, which is done for Vancouver, which looks at both those together. It gives you an idea by neighborhood or block where the hottest parts of the city are in the summertime. And this can be used then to deploy, for example, medical services in the summertime. It's where cooling centers can go, for example, or where they should go. So really a really great tool for a variety of means. This LiDAR, it's great stuff. And when we get down to the detail, this is what it looks at. You actually have all these tree canopies mapped out. This illustrates the height of these trees, which can be really interesting. So you can look at where are the tallest trees, where are the shortest trees. You can't do species, but you can differentiate between conifers and deciduous trees. So that can be very important as well, especially when you're looking at, for example, summer versus winter cover. So you can get a lot of great data. And even with tree heights for urban forest strategies, we try to find the most significant trees. Well, we know already where the tallest trees are from this LiDAR, so then we can go on the ground and find out where these tall trees are, how tall they are, and what they are. So it really provides a lot of great data to work with. A lot of urban forest strategies also do have inventories, so detailed tree by tree inventories. So some cities like Vancouver will have quite a detailed street tree inventory. And when this is available, that is also very important because we can look at how much of that street tree inventory is of what species. In the case of Vancouver, there's a high number of maple and cherry trees, which is important because then there's certain management criteria or pest or disease issues that come with having too much of one species on the landscape. So we combine this is sort of the two input data. If you have inventory data for street trees, it's used, and also this canopy data is used at a sort of a holistic high level. So once you know what's on the landscape, then you want to look at, okay, what are the trends for that city? And there's another tool called iTree analysis, which looks at ortho photos, old ortho photos, and we you look at what changes have been taking place to that canopy. So as an example, this is from Westminster. It shows that over time there's been a canopy loss across the city. This is super important with consultation, public consultation, to show what's been happening, and if the status quo continues, what could possibly happen to the cover of the forest across the city. You can also compare with other cities and what their canopy is. Of course, every city is different. Some cities have massive, natural area parks. Some are very densified and old, so it's not a great idea to compare too much with other cities. But it does help to see sort of how cities are doing relative to each other. You can use this data from Westminster to look at statistics per neighborhood. So how much of each neighborhood is covered by trees, buildings, impervious surfaces. Sorry. Yes. Anyway, so this, and also, sorry, as well as neighborhoods, you can look at different zones. So it's very different with planning when you're looking at, single residential neighborhoods compared to industrial zoning neighborhoods. The expectations on what the tree cover should be in those areas and the targets are going to be quite a bit different. And so now you have an idea of what exists across the landscape, what the trends have been, and then through consultation, there's a long process of analysis looking at where you want to go. So generally, you want to look into the future. Where do we want our canopy to be? You manage different landscapes in certain ways. So private lands, again, have to be managed differently than public lands. And public lands are often split up into street and boulevard trees or natural areas and parks. You sort of have these three categories, a sliding scale with each of them, and you look at how you're going to try and get to a target and what that target should be and how far away that target should be. And this gets really interesting because I'll get into this, you start looking at resources. Okay, how much is it going to cost to get to that target within these different areas of the city? And what tools do we have to make that happen? But generally, you land on a scenario or a target that you want to aim for. And then once you have that target, then you can start looking at tools on how to get there. In consultation as well, we find visual representations of canopy cover are very important. So you can see again from the top photo to the bottom photo, from 85 to 10%, very different feeling in terms of the canopy cover and what it means to the feel of that neighborhood or that landscape. And then we start getting into the numbers, start looking at, okay, well, we want to get to this target. How many trees do we need to plant in the public realm, in the private realm, to meet that target over X number of years? In this case, it was 20 years. As you start implementing, these tools and strategies, then you start to track how you're doing over time to get to that target. In the document itself, we tend to talk about 5 different chapters. The first one is protecting trees. So you're looking at what policies, what enforcement, what incentives there are to protect trees, both on private and public realm again. Planting trees, of course. What are the incentives to have people or encourage people to plant trees on the private lands? The private lands generally, encompass the majority of the landscape. So that really is the biggest opportunity. There's often the most plantable spots on private lands as well. So that's a challenge. You can't force people to plant trees on their properties, but there's incentives, there's education, which does tend to help. And then planting trees, of course, on the public realm can be very challenging due to constraints. We have cities, streets and sidewalks, infrastructure. It can be quite challenging. Managing trees for health and safety. I'll get into resourcing later on. This is a big one. Trees are not cheap to plant and maintain. They die, they become hazards, they have disease and pest outbreaks. So understanding and being realistic about managing that urban forest is very important. Engaging the citizens is again key. The consultation process is huge for urban forest strategies, especially when adopting that target, that long-term target for canopy cover. And then monitoring the status and condition of those urban forests is very important to see how you're doing, how the health of those trees are doing, how that canopy cover is recovering or changing over time. I mentioned before, again, when we look at these strategies, it's a very different suite of options when you're looking at a natural area park, for example, where you have lots of soil volume, lots of growing space. You can grow these big, beautiful native trees compared to, for example, an industrial setting where you just have boulevards, small areas, container plantings. You're not going to get the same tree cover. You're not going to get the same species or the same sizes. So the goals of the urban forest strategy, we have to be realistic about what you're going to get in these different areas. And then out of the urban forest strategy, there are things that come out of it often that help to reach those goals. So more detailed tree planting guidelines for streets, for example. Guidelines and design guidelines for different neighborhoods on what should be done to ensure that canopy target can be achieved. And again, design guidelines, especially for engineering. Streetscapes are really tough. And again, it's really dependent on what your hydrology is, what your soil volumes are, as to what you can get in those spaces. And really, if you don't get that soil volume and hydrology right, you're just not going to have a healthy tree in the long term. And so they may look great for 5 years, but then they're just going to be an ongoing problem for the city to manage and maintain. One thing we're doing right now, we've just released with Metro Vancouver, is it's a tree bylaw regulatory toolkit. So this is something we worked with them for a long time on. It's just coming out, and it looks at for municipalities, trees in different areas of the city, what the regulatory tools are that are available to manage them and to protect them. And so that's been a very interesting process, and that's coming out. I think it's just being finalized now, so that'll be out very soon for cities to reference. So a great tool in terms of sort of the policy that's available. Biodiversity strategies. And I apologize, I'm going quickly here just because I can see the time is running out. We've done a number of biodiversity strategies. We're just finishing one with New Westminster, looking at one in Bellingham. There's, when we deal with trees, we deal with natural areas often. And when you start looking at wildlife and species and plants, we want to protect as much diversity as we can in our urban landscapes. And that means we want to protect these large natural area hubs, which are core areas for species to survive. And you want to have them connected together. You want to avoid having genetic islands in certain groups of species. So that's a very interesting exercise to go through as well. And once you have that sort of canopy data, and a lot of that data analysis, it's a very logical next step to an urban forest strategy. Another project we just finished, which is a very interesting one, again, just coming out, is we completed a wildlife connectivity analysis for Metro Vancouver. So we looked at a bunch of focal species that represent different habitat types or different guilds of species across Metro Vancouver, and used it's a prioritization software called Coulthard, which basically analyzes the connectivity of different habitat patches and basically values them based on their importance for that species to move around the landscape. Really interesting stuff. And these data is all combined together into a final layer, which basically shows the value of these different habitat types across the landscape. And this has been actually completed for each city as well. So Metro Vancouver is releasing this information, which we hope will help cities to start to develop these green infrastructure networks and prioritize which natural areas they want to focus on enhancing and protecting based on science. Invasive species strategies, again, with the changing climate especially, invasive species are a huge risk to biodiversity and to the urban forests. Understanding those species, the outbreaks, where they are, how to control them and eradicate them at an early stage, or manage them if they've gotten too out of hand, very important. So again, that involves inventories and analyzing at a high level. Invasive species, you can go in and treat an area, and if you don't maintain that area or treat it properly, it'll be in the same state in 2 or 3 years, and you just lost all that that sort of valuable effort. So invasive species strategies, very important for a city. Again, community support, I touched on it through the presentation, but what we found for all these projects, for any environmental policy, is the consultation process and community buy-in is huge. In particular, again, because most trees are growing on private lands, so encouraging people to keep them, plant and maintain them is a big part of achieving that that canopy covered target. And finally, resourcing, I've touched on this as well. You know, there's all these great strategies, all these things we can do. We can plant trees, we can maintain trees, but it all takes resources. So at the end of the day, with these urban forest strategies, one of the biggest pieces at the end is figuring out what can realistically be done within the resources of the city. So it takes money, it takes staffing, it takes operations to plant, maintain these trees over time. And if you don't have those resources, it's unfair to have expectations that won't be realized. So this is a really important part of urban forest planning, is looking at what can be done. And that allows you to prioritize what you're doing to get the best bang for your buck in terms of planning and management of the urban forest. Oh, I love one more thing, emerging trends. This is some really interesting stuff that I think will be coming much more prominent in the next 5 years, is both remote sensing for satellite imagery and infrared cameras. So in Melbourne, they're doing a lot of great work, and other places, but in terms of linking remote sensing from satellite imagery to this ground data, and then being able to really quickly sort of monitor the state of the canopy in the urban forest over time. And this is the extent or the area of it, as well as the health of it. So this is an example of these, in Melbourne, they're finding they have such a huge urban forest and such an aggressive goal for planting that, you know, monitoring the health of these trees is very challenging. So they're starting to try to use infrared cameras. They drive around, and basically these cameras can see the health of the trees and the leaves and the water content of them. So you can look at drought stress and health of these trees really quickly using these infrared cameras. So some really interesting technology, which again is just making it more efficient and cost effective for managing these urban forests. And this is my final slide. Thank you. I apologize. That was a lot of information. This is a picture of old Vancouver. It was clear. And I think the one thing I like to stress to people is we are very lucky living on the West Coast. We have an incredible climate for growing trees. We grow the biggest trees, which is one of our greatest assets. And, you know, we do cut them down. We have cut a lot down. We do, but they do regrow fast. And so there's a lot of hope moving forward that as long as we provide the right growing space for these trees, they will grow, and they will grow back to beautiful, beautiful trees in our landscape. There we go, Bill.